This lesson on similar figures, we are going to identify similar figures, their corresponding parts, and how to use proportions to find missing values in similar figures. First of all, what are similar figures? They're two or more figures that would be congruent if one was dilated. In other words, they're the same shape, but not the same size. The symbol for similar figures is just the curved part that sits on top of the congruent symbol. So if you remember, the congruent symbol looks like this. This part means same shape. This part means same size. So by just taking out the part that means the same size, then we have just figures that are the same shape. The characteristics of similar figures are that the angles stay congruent. In this case, if this angle was 58 degrees, then this angle would be 58 degrees. The corresponding sides, however, do not have this, are not congruent, but they do have the same ratio. So in other words, let's say that this side is 2 units long and this side is 4 units long. So the ratio of the sides would be 2 to 4, but you'd simplify down to 1 to 2. That means that the ratio of all the sides would have to be 1 to 2 if these two figures were going to be similar. So if this side was 3, this side over here would have to be 6 because 3 to 6 would also be the ratio of 1 to 2. And they would have to be the same all the way around. To determine if two figures are similar, you divide the corresponding sides. It doesn't matter whether you divide small by big or big by small unless it specifically asks. The ratios just have to be the same for all the pairs of sides. So if I take 38 over 57, that has to be the same as when I take 20 over 30 and when I take 26 over 39. All three of those would have to be the same ratio. When I divide them out, I'd have to get the same number in order to say that these two triangles are similar. They do all happen to come out to be 2/3 or 0.6 repeating, so I do know that these two triangles are similar. If you get a picture like this where it just gives you one side, but notice the tick marks mean that all of these sides are 4 and all of these are 2, they would automatically be similar because the side ratio would be 2 to 1 all the way around. To find a similarity ratio, that difference, you will just divide. Usually you take the second one divided by the first one unless it specifies which way it wants you to go. It might say find the similarity ratio from the first to the second or from the second to the first. Then you know which way to go. In this case, if I wanted to actually find the similarity ratio, I might take 57 divided by 38, or I could take 30 divided by 20, or I could take 39 divided by 26. It doesn't matter. All three of them will give me exactly the same of 1.5. That means my scale factor to go from this triangle to this triangle would be multiplying by 1.5. If two figures are similar, then you can write a similarity statement. It's just like a congruent statement, only you put just the similar figure in between instead of the whole congruent symbol. So it would still be triangle, this is similar to triangle, this, for whatever corners you have labeled. Just put your corresponding parts together. So in this case, we'll put that A goes with F, so triangle ABC would be similar to triangle F would go first because A did, and then you would just go around. B would go with D, and C would go with E. So it would be triangle ABC, it would be similar to triangle FDE. Make sure you put your corresponding parts in the right places. If two triangles or two figures are similar, like in this case, you can find any missing values using the fact that you know that the scale factor has to be the same across the board. You just set up a proportion. Okay. If we know these two triangles are similar, then we know that the corresponding parts match up and have the same ratio. So the ratio of 40 over 25 would have to be the same as the ratio of 24 over x. So you can set that up as a proportion. 40 over 25 would have to be the same as 24 over x. You could have also, instead of 40 over 25, you could have used 32 over 20. They'd be the same, it didn't matter. And then you just cross multiply and divide. So I would get 40x equals 24 times 25 is 600. And then I would divide by 40 and I would get 15. So my missing value here is 15. Okay. You might have to set a more than one proportion in any given problem. For example, this example says if you want to enlarge a 3-inch by 5-inch picture so that the longer side is 2 feet, what would the length of the shorter side be? You're going to have to check that out. So you go 3 over 5 is the ratio that I have. And that would be equivalent to what? And now it says the longer side is 2 feet. If the longer side is 2 feet, that would mean that it correlates with the 5 inches. So you'd put the 2 feet over here. You can change that to inches if you want. If you'd rather put 24 inches, since these are inches, you certainly can do that. The only difference is when you write your answer then, if you change this to inches, your answer will be in inches. If I leave this in feet, my answer will be in feet. It doesn't matter either way. You just have to know when you write your answer. You have to label and make sure that everybody knows. So if I get 5x equals 6, and I take 6 divided by 5 to get my answer, I get x equals 1.2. Since I left this in feet, my answer would be in feet. My shorter side of my 3 inches would go to 1.2 feet. One thing that you have to remember is equivalent proportions, proportions that have the same components and give you the same answer. So that means that your neighbor might have set up something different than you did. For example, a neighbor may have used 32 over 20 instead of 40 over 25. That would give them the same answer. They could have also, instead of setting up this way, maybe they set up 24 over or 25 over 40 and x over 24. Completely okay. Over here, they maybe would have said, wait, my 5 inches goes to 2 feet. So what would my 3 inches go to? Those would be equivalent proportions because when you solve them, you're going to get the same answer. You're still going to get 1.2 feet. It's just a different way of setting up the same problem. Things to remember about ratios. A lot of times they'll be they don't absolutely need to be the same, but the units of measure, a lot of times they ask you for them to be the same. So in that case, you would have wanted to change this to inches. You don't have to, just that's why I said make sure and label your answer so you know what term your answer is in. And if you can simplify down to lowest terms your ratios, that's always helpful. When we set up this problem, we wouldn't leave it as 20 over 30. We would simplify it down to 2/3. That would be in simplest form. That ends this lesson. Please check your pacing guide for the suggested problems.